Welcome to Brain Vision.
Our question says it wants us to determine the magnetic field midway between two long straight wires that are a distance r apart, where r is 2 centimeters or 0.02 meters. That means the midway point between each one, or R1 and R2, is equal to r over 2. It's halfway between the distance between. So R1 is equal to R2 is equal to r over 2, or 0.01 meters. I1, we're told, is just equal to the current I, and I2 carries the current 25 amperes. So for part A, we're going to assume they're going in the same direction, and B, we're going to assume they're going in the opposite direction. So for part A, in order to figure out the magnetic field, the total magnetic field, B, is going to be equal to the magnetic field of the first wire, B1, minus the magnetic field of the second wire, B2. The reason it's minus is because we're considering them to be going in the same direction in this situation. So if they're going in the same direction, they should be subtracted from one another. So we'll plug in our expressions for magnetic field. So for 1, it's going to be the magnetic field of magnetic permeability of free space, which is 4 pi times 10 to the minus 7 newtons per ampere. You can look more up about that constant if you want to, but it's a very common constant that you'll see over and over again, multiplied by I1 divided by 2 times pi times R1, minus mu naught times I2 divided by 2 times pi times R2. Well, the mu naught over 2 pi R1 is the exact same as mu naught over 2 pi R2, since R1 is equal to R2. So what we find is that expression, again, mu naught is 4 pi times 10 to the minus 7. So the pi in that is going to cancel with the pi on the bottom. What we end up with is 2 times 10 to the minus 5 Tesla per ampere as our solution to mu naught over 2 pi R1. And then that's what we pulled out front, since that was common in both. And then what we have is I1 minus I2. But I1 is just equal to I, and I2 is 25 amperes. So we can go ahead and box that in as our solution for part A. Part B, we're going to be doing a very similar thing, but this time we're going to be adding them since they're flowing in the opposite direction. So we have B is equal to B1 plus B2. Again, B1 and B2 are the same. So the only difference here is we're going to be adding the currents instead of subtracting them. So what we end up with is the exact same expression for mu naught over 2 pi R1, or mu naught over 2 pi R2, since they're the same, of 2 times 10 to the minus 5. And the units here were Tesla per ampere. And again, that was the common constants between the two, so that gets pulled out front. And then what we're left with is I1 minus I2, or excuse me, I1 plus I2. I1 is I, and again, I2 is just 25 amperes. And so we can box that in as our solution for part B.